Alright, so now we're going to go through our last video and the third video of this section, complex fractions. Alright, so what are complex fractions? Well, a complex fraction is a rational expression that has at least one fraction in its numerator or denominator or both. So pretty much it is a fraction within a fraction. So if we look here, we have the overall fraction here, where this is my numerator and this is my denominator. Well, if you look, we have fractions in both our numerator and our denominator. Same thing here. Here is my overall fraction bar, here is my numerator, and here is my denominator. I have fractions within. Right? And then for this one, this is my overall fraction, and my numerator is actually two fractions being added together, and my denominator is two fractions being subtracted together. So this is just showing different kinds of complex fractions. Pretty much it is a fraction within a fraction. Right? So it's either your numerator or your denominator has a fraction within it. And in some cases, as we showed here, it could be both. Alright, now, these two problems we're going to talk about specifically and go through. Alright, the difference between this here is this first one has this plus sign in our numerator. So this numerator is not just one fraction, it's broken up between two fractions. So anytime that you see an addition between your fractions or within your numerator, you are going to use the method that we're going to do first. In this one, when there's nothing that's being broken up, yeah, there's a plus sign here, but it's part of the numerator of the fraction. This one's broken up between two separate fractions. So when you don't see two separate fractions in your numerator or your denominator, this one gets treated as x plus 3 over 2, and fraction means the operation division, so then we divide by 2 over x minus 4. And then we do what we learned in the other section. Alright, so these two ways, these two types of complex fractions, it's important that you can identify the difference between the two, so that way you know what method to use. Alright, so let's go through and do our first example. Alright, so here we have a complex fraction because within my numerator I have two fractions, and within my denominator I also have a fraction. And now since this fraction, these fractions are being broken apart and are separated by an addition sign, and so is this fraction in the number 1, we know that we're going to have to use the first method that we haven't really talked about yet, but we're going to use how to solve for this type of problem. Alright, now the way you do this is you identify all of your denominators. So my denominators are x, y, and y. Alright, and then you are going to find your least common multiple or your least common denominator. So what you want to do is you need to find, well, which, imagine that you were trying to add all these together. What denominator would you need for them to be all the same? Well, in these two we have the y and a y, but we're missing the y here. In this one we have an x, but we're missing the x here and here. So if I multiply this by y, and these two by x, that will give me my common denominator of xy. Right? That will make all of these common. Now once you find that common denominator, and we'll also talk about the least common multiple, we'll talk about that in class, but once you find that, you multiply everything by that. Every single thing by that xy, or that least common denominator, or that least common multiple. Everything gets multiplied by it, even the one that doesn't have the denominator with it. By multiplying everything by xy, we're increasing, or we're changing this value consistently throughout this fraction, so we're not actually changing it, we're just manipulating it. Alright, and then the x and the x will cancel out, and I'm left with y times 1, or just y. The y and the y will cancel out, and I'm left with x squared. Over top of, the y and the y cancel out, so I'm left with x. And then here, there's nothing to cancel out, so it's plus xy. Alright, now, if you could reduce or simplify, you would look to, but here there's nothing that we can really factor out to reduce or change anything, so this will be your final answer. Alright, but that's just showing that we would clear out, and now with this fraction, within our numerator, we do not have a fraction, and within our denominator, we do not have a fraction. So we got rid of the complex fraction to a simpler fraction, and then we will still look to simplify if possible, but here we couldn't. Alright, that's it for this question, and then there's one more and then we're done for this video. Alright, when we look at this fraction here, we know that this is a complex fraction because we have a fraction in our numerator and a fraction in our denominator. Now, unlike the last fraction, where this one was being broken up with a plus sign in our numerator and our denominator. This one is just a complete fraction and a whole fraction, so nothing's being broken up. Like here, we had 2 fractions in our numerator, 1, 2. Here we had 2 fractions in our denominator. Here we only have 1, and we only have 1. So when that happens, the easiest way to do this is just rewrite it. So 2 over x plus y, and fraction means division, so it's divided by 5 over x plus y. And then we use our rules. We keep, we change to multiplication, and we flip. All right, now this one works out nice and easy because our x plus y will then eliminate, and then we would just be left with 2 over 5. All right, so when it's broken apart and you have more than one fraction in your numerator and your denominator, or where your fractions and you have a fraction and then a constant, you then want to multiply by your LCM or your least common denominator. Then from here, if you only have one fraction in your numerator and that's it, and one fraction in denominator and that's it, and nothing else, there's nothing else in your numerator or denominator with it, you can simply just rewrite it as a division problem, and then we use the properties that we learned before. Alright, that is it for this video, and that's it for this section.